Hi, Mr. Richards here, and today's lesson is on weighted averages. We'll also be solving mixture problems in this lesson, but first, the definition of weighted average is the sum of the product of the number of units and the value per unit divided by the sum of the number of units which is going to be represented by M. Mixture problems are problems in which two or more parts are combined into a whole. And these are the problems we'll be solving today. Our first example is a mixture problem. Mandisha feeds her cat gourmet cat food that costs $1.75 per pound. She combines it with cheaper food that costs 50 cents per pound. How many pounds of cheaper food should Mandisha buy to go with 5 pounds of gourmet food if she wants the average price to be $1 per pound? So let's first take a look at what we have. On the left side of our table here, we're going to write our cat foods. So we'll first start off with our gourmet food. We're going to mix that with the cheap food, and that's going to combine to be the mixed food. Now on top here of our table, we're going to write our units in this column, and that's going to be per pound. We're then going to have our price per unit there. And then that will result in a total price. So let's fill in what we know. We know that she's going to do gourmet cat food with 5 pounds. So we're going to write units for gourmet as being 5. We know the price per unit of that is $1.75. To find our total price for that, we can take our 5 units multiplied by our $1.75 to get $8.75. Now the cheap food, we do not know the amount she's going to buy yet. That's what we're trying to figure out. So we're going to set a variable for this, and let's just call this W. Now our price per unit here is 50 cents, and we do need to write a total price here. Well, that's simply going to be our 50 cents times W. Think about how we got the total price here by taking the $1.75 times 5. Our total price for the cheap food is going to be the 50 cents times the W. Now it comes down to our mixed category. For our mixed, our units are going to be the 5 plus the W to get us our mixed here. Now, this price per unit is not going to be $1.75 plus 50 cents. The price per unit is going to be the dollar per pound we want right here. We want the price per unit to be $1. Now, how do we get our total price here? The same way we got these. We're going to take our price per unit and multiply it by our units. So our price per unit of $1 multiplied by our units, which was 5 plus W. Now that I have this set up, I have my total price here for gourmet and cheap being $8.75 plus the 50 cents times W. I have my total price here being $1 times the 5 plus W. Well, those are the two sides of the equation I'm going to set up. The left side being $8.75 for the gourmet plus the 50 cents times our W for our numbers of units here. That's going to equal our $1 times the 5 plus W. So the total price of the gourmet and cheap needs to equal the total price of the mixed, and that should kind of intuitively make sense here. And now we need to solve the equation. So my first step is going to be to distribute. On the left side, we're still left with $8.75 plus 0.5 W is going to equal 1 times 5 is 5, and 1 times W is just W. Now we have an equation with variables on both sides, so we need to move our 5/10 W to the other side by subtracting it from both sides. And it is good to know that this single W over here is just 1 W. And so as I subtract these things out, we're left with $8.75 on the left side equals 1 W minus 5/10 or 1 minus a half is just a half. So plus 0.5 W. Now I need to move this 5. So we'll subtract 5 from both sides. We're left with $3.75 is going to equal 0.5 W. Lastly, divide by the 0.5 on both sides. $3.75 divided by 0.5 is 7 5/10 equals my W. What does this tell me? She should buy 7.5 or 7 5/10 or 7.5 pounds of cheaper food to go with that 5 pounds of gourmet food that she was buying. Example 2 is a percent mixture problem. A car's radiator should contain a solution of 50% antifreeze. Bai has 2 gallons of 35% antifreeze. How many gallons of 100% antifreeze should he add to his solution to produce a solution of 50% antifreeze? Well, let's set up a table first, and our backbone of the table's here already. On the left side, we're going to write our solutions that we have and want. And so we have 35% solution. We have a 100% solution. And we want this to become a 50% solution. Next, on top of the table, we can look at our amounts. So here we're going to first have our amount of solution, and this is going to be in gallons, and our right column is going to be our amount of antifreeze. So the 35% solution, we are told that he has 2 gallons. So we're going to put that 2 gallons in. We do not know how many gallons of 100% solution he needs. So we're going to say that that is just G. Which leaves us then with our 50% solution being simply 2 plus G. Because I'm going to mix the 35% with 2 gallons, the 100%, that's G gallons, to get 2 plus G of 50%. Next, to get our amount of antifreeze, what we're going to do is take our percentages and write them as decimals. So this 35% solution is going to be 0.35 for the 35% times that amount of solution we're using, which is 2. Then, for the 100%, this is going to be 100% as a decimal, which is 1.00, as we move that decimal point over twice to the left, times our amount of solution, G. Then, to get our total amount here, we're going to take our 50% as a decimal, 0.50, times that amount, which was 2 plus G. And so as you can see how we did this, we have our 35%, 100%, which is going to mix into our 50%. We know we have 2 gallons of 35%. We know we need G of the 100. We're looking for G. And so our amount of solution overall is going to be 2 plus G. Then in the last step of our table, to get our actual amount of antifreeze, 35% times the 2, 100% as a decimal times the G, and then 50% times the 2 plus G. And now this is going to give us what our equation is going to be. We have our amount of antifreeze of 35% being 0.35 times the 2 plus our 100%, 1.00 times the G, and that's going to equal our 0.50 times the 2 plus G. So this plus this needs to equal this. And now we can solve. Let's start simplifying both sides. 35 hundredths times 2 is 0.70, or just 0.7, plus the 1G is going to equal, now we need to distribute, the 50%, or 0.50 times 2 is just 1, and 0.5 times G is 0.5, or 5/10 G. Let's get all our G's on one side, subtract the 5/10 G from both sides. We're left with 70 hundredths, or 7/10, however you want to write it, plus 5/10 G equals 1. Then, subtract our 70 hundredths, or 7/10. We're left with 5/10 G equals 30 hundredths. Lastly, divide by the 5/10 from both sides. And G is going to equal 0.6, or 6/10. So what this tells you is I should add 6/10 gallons of the 100% antifreeze to produce that 50% solution. Next, we have uniform motion problems, and these are problems in which an object moves at a certain speed or rate. With our uniform motion problems, we're typically going to be using an equation: distance equals our rate of speed times, well, the time. Sometimes you'll see it d equals rt. Example 3 deals with the speed of one vehicle. Nita took a nonstop flight to visit her grandmother. The 750-mile trip took 3 hours and 45 minutes. Because of bad weather, the return trip took 4 hours and 45 minutes. What was her average speed for the round trip? Now we know that she did not travel the same amount of time on each portion of the trip. So we need to find the weighted average of the plane's speed. We're asked to find the average speed of both portions of the trip. The first thing we're going to do is find the rate of the going portion, and then we'll find the rate of the leaving portion. Well, if distance equals rate times time, if we simply divide by t on both sides, we can come up with a formula that our rate is going to equal our distance divided by time. So our rate for her going is going to be the distance of 750 divided by 3.75 hours, as we have miles per hour, and 3/4 of an hour is 45 minutes. So this is going to be then 200 miles per hour going. What about her return trip? Well, for her return trip, rate's still going to equal distance divided by time. So rate is going to be still 750 miles for the distance over 4 and 45 minutes is 4.75 hours. So this rate is going to be about 157 9/10 miles per hour. Now, since we're looking for a weighted average, we cannot just add these up and divide by 2. We cannot just average the speeds. We need to find the weighted average for the round trip. So m is going to equal our rate of going multiplied by our time of going Remember, rate times time is our distance. We're going to add that to our rate of return. Multiplied by our time of return. Now this is all going to be divided by our time of going plus our time of return. So now we just substitute in. Our rate of going was equal to 200. Our time of going equal to 3.75 plus our rate of return was the 157 9/10 multiplied by our time of 4.75, and that's going to be divided by our time of going, 3.75, plus our return, 4.75, which of course is 4 75/100. So m is going to equal 200 times 3 75/100 is 750, plus our 157 9/10 times the 4 75/100 is the 750 again, all over our 3 75/100 plus our 4 75/100, which is 8 5/10. This is about 1,500 divided by 8 5/10, which is equal to 176 47/100. So our average speed was about 176 miles per hour. Now it's time for one of the most classic algebra questions ever. Example 4, the speeds of two vehicles. A railroad switching operator has discovered that two trains are heading toward each other on the same track. Currently, the trains are 53 miles apart. One train is traveling at 75 miles per hour and the other 40 miles per hour. The faster train will require 5 miles to stop safely, and the slower train will require 3 miles to stop safely. About how many minutes does the operator have to warn the train engineers to stop their trains before they collide? Okay, I added the collide part, but the first step here is to draw a diagram. So we have train 1 going this way, and we have train 2 coming at it this way. Right now they are only 53 miles apart. Train 1 takes 5 miles to stop. Train 2 takes 3 miles to stop. And if you wanted to write in the speeds, train 1 is going 75 miles per hour, and train 2 is traveling at 40 miles per hour. So that gets all our information out there. We do want to calculate one thing real quick, and that is how far they have before they collide. Well, they're 53 miles apart now. We need to subtract away the 5 plus 3, because in reality they have 53 minus 8, which is 45 miles to stop. Just because they're 53 miles apart right now, they only have 45 miles really to get stopped. Now let's set up our table. We have our fast train. We have our other train. We're not going to call it slow. We're going to call it the other train. And now remember, distance equals rate times time. So we have our rate, we have our time, and we're going to have our distance equaling our rate times time. Well, our fast train is traveling at 75 miles per hour and the other train at 40 miles per hour. The time, we don't know, but it's going to be the same. It's going to be m for minutes. And if distance equals rate times time, then this is going to be 75m, and this is going to be 40m. So now the distance traveled by the fast train, which is 75m, plus the distance traveled by the slow train, which is 40m, is going to equal the 45 miles that they have before they collide. Well, now we get to solve this. 75 plus 40m is 115m equals 45. If we divide by 115 on both sides, we get our m to equal about 0.39. Now that 0.39 or 39 hundredths is the amount of hours. And so if we take our 60 minutes in an hour, multiply it by the 0.39, we're going to get 23 4/10. So what does this mean? The train operator has about 23 minutes to warn before they collide. And that is it for this lesson on weighted averages. Good luck.